Okay, this is Mr. Duncan. Today we are going to convert fractions to decimals. We will do this by first writing each mixed number as an improper fraction. Once we have done that, we will then use long division as our method for rewriting these fractions as decimal answers. So to begin with, we have -1 3/4. We need to convert this into a improper fraction. In order to do so, we will take this -1 and convert it into fourths. There are 4/4 in one whole. So this will become 4/4, and we already had 3/4, so 4/4 and 3/4 becomes 7/4. The quick-fire operation that we do, and we oftentimes teach, is that you multiply whatever your whole is by your denominator. When we do that, we end up with 1 times 4 is 4. We then add that number that we receive to the top number, and that will be our new numerator. So if we do so, we get 4 times 1 is 4. 4 plus 3 is 7, so we end up with 7/4. -7/4. From here, we are now going to use long division in order to do this problem. We have -7/4. The way we write this using long division is we take our divisor, that's the number on the bottom, and we're going to place it into this diagram, which most of us are pretty familiar with. The top number is called the dividend when you're doing a division problem. So the way we would write this is we have 4 going into 7. Okay, so we see how many 4s we can pull out of 7, and we can only pull out 1. If we tried pulling out 2, that'd be too much. 1 times 4 is 4. We will now subtract what we've taken out of 7, which is 4. So 7 minus 4 is 3. Okay, 4 does not go into 3 evenly. So what we will do is, this is actually called partitioning. We're going to take these 3 holes that we have left over, we're going to break them up into 30 pieces. In fact, we make them into 30/10. So now we see how many times 4 goes into 30/10. And we end up with the number 7. So we get 1.7. 7 times 4 is 28. So we were able to use 28 of these 30 pieces. So we're going to subtract those out, and now we have 2 pieces remaining. We actually have 2/10 remaining. We can't break up our 2/10 into 4 equal parts, so we're going to partition these 2/10 into hundredths, and that makes 20 hundredths. So now we can divide 20 by 4. That divides evenly 5 times. 5 times 4 is 20, so we have used all of those 20 pieces when we did this division. That leaves a remainder of 0, and this then will be our answer. We started with a negative number, so this should remain a negative answer. So our quotient, when we divide 7 by 4, it becomes -1.75. And I would also emphasize that not just saying 0.75, because what does that mean? I would also read this as -1 75 hundredths, because that's really what we've done. We've converted this fraction, which is in fourths, we've converted it into a decimal number. And decimal numbers are really just fractions in base 10. So our first number here is in tenths, our second number is in hundredths. So we can read this as -1 75 hundredths. For letter B, we're going to do a similar process as we did in letter A. So first we're going to multiply the 9 times the 2. This tells us how many ninths we're going to get out of these 2 holes. That gives us 18. We're going to add that to our 1/9 that we already had. So these are the 2 operations we're going to do. So 9 times 2 is 18, plus the 1 is 19. So this will convert to 19/9. And now we're going to do the same process that we did in part A. We're going to use long division and see what this becomes as a decimal answer. So the divisor, of course, goes on the outside, and the dividend, which is the top number, goes on the inside. And we see how many groups of 9 we can make out of 19. And it turns out we can make 2, which makes sense because that's what we already had as a whole. 2 times 9 is 18, so we used 18 of those 19 pieces. And we're left with just 1 whole. Now 9, we can't divide 1 whole into 9 pieces. There's not enough to divide evenly, or to divide at all. So we're going to take this 1 piece and break it up into tenths. And that makes 10 tenths. So now we see, how can we divide 10 into 9 pieces? Well, we can divide them evenly once. So 1 times 9 is 9. We subtract that, and we end up with 1 piece left over. So we do the same thing again. We now cut our tenths into hundredths, and we have 10 hundredths, same as 1/10. And now we see that 9 goes into 10 just once. And now we're seeing the same pattern that we had here. 10 minus 9 is 1. We drop down to 0. Now we're doing 10 minus 9 is 1 again. And we're going to continue the same pattern over and over. In fact, this remainder, we're getting a repeated remainder, 1 each time, which means that we are going to have a repeating decimal. So we can write 2 1/9 as a repeating decimal. It is equal to 2.1 with a bar over the 1. And this would be our answer.